Pollution is and always has been a dirty word. With 7 million annual deaths, heart disease, lung disease, and cancer come to mind. We associate air pollution with cars, trucks, factories, old school cooking stoves, and burning of forests. These pollutants are to blame for the smog that we see in many cities across the world. While there's some amount of pollution everywhere we go, this is especially visible in developing countries like India and China. But let's take a few steps back and look at the big picture for a minute. The entire spectrum of small particles in the air. Tiny solid and liquid particles suspended in the air are collectively called aerosols. The bulk of aerosols, about 90% of them by mass, have natural origins. Volcanoes shoot out massive columns of ash into the air along with sulfur dioxide and other gases, all of which are aerosols. Forest fires release partially burnt organic carbon called soot. Many plants produce gases that react with other substances in the air to produce aerosols. In the oceans, certain algae produce sulfurous gases which can be converted into sulfates. Sea salt from the oceans and mineral dust from desert sandstorms are two of the most abundant natural origins of aerosols. It's only the remaining 10% which are human-made. Though they are less abundant than their natural counterparts, human-made aerosols can still dominate the air around urban and industrial areas. Fossil fuel burning produces large amounts of sulfur dioxide, which combines with water vapor and other gases to produce sulfate aerosols. Biomass burning, still a common method of clearing land and consuming farm waste, creates smoke made up of organic carbon and black carbon, both of which are aerosols. Automobiles, incinerators, smelters, and power plants are major producers of sulfates, nitrates, black carbon, and other particles. Deforestation, overgrazing, and drought alter the land surface and increase how much dust aerosol enters the atmosphere. Even indoors, cigarettes, cooking stoves, fireplaces, and candles are all sources of aerosols. These small particles stay in the air, but at scale, they also interact with the natural world in interesting ways. 1. Aerosols act as the seeds on which clouds form. Most airborne particles help form clouds, and it doesn't matter if they're crystals of sea salt from the ocean or sulfate molecules from industrial chimneys. More aerosol particles can lead to more but smaller cloud droplets. Aerosols can also have an effect on rainfall patterns. High loads of aerosol lead to a delay in the onset of rainfall, but once it sets in, the rainfall is also heavier and more widespread. 2. Aerosols influence how much carbon dioxide gets drawn out of the air by plants. When aerosol levels are high, the amount of carbon absorbed by some ecosystems increases, like forests and croplands, and in others, like grasslands, carbon absorption decreases. They can even add nutrients, for example, to the oceans and to land. These nuances are yet to be studied in great detail, but the preliminary science suggests that aerosols can uptake the level of carbon dioxide and nutrients absorbed by plants, soil, and the oceans. 3. Aerosols also make clouds more reflective of sunlight and potentially longer lasting. Most aerosols reflect sunlight, but some also absorb it. Bright colored particles like sulfates, nitrates, and salt tend to reflect radiation in all directions and back towards space, producing a cooling effect. Darker aerosols like black carbon, organic carbon, or brown carbon, and some kinds of dust absorb significant amounts of light and produce a warming effect. Ultimately, humans are emitting a lot of extra aerosols, and as far as the science goes, they're having a net cooling effect. An international team of scientists has quantified this cooling effect, saying that the Earth would be 0.5 to 1.1 degrees Celsius warmer if aerosol pollution were to suddenly disappear. Because aerosols scatter light, they can have a profound impact on the climate as well. In 1991, the eruption of Mount Pinatubo in the Philippines emitted more than 20 million tons of sulfur dioxide into the atmosphere. The gases were released over 60 kilometers above the Earth's surface, creating particles in the stratosphere. These bright particles remained above the clouds and didn't get washed away by rain. They stayed in the atmosphere for several years. Climatologists had predicted that global temperatures would drop because of this sulfate infusion, and they were right. After the eruption, global temperatures dropped by about 0.6 degrees for about 2 years. The Pinatubo eruption isn't a unique event. Large temperature-altering eruptions happen at least once every decade. And climate models estimate that aerosols have had a cooling effect that has counteracted about half of the warming linked with greenhouse gases since the 1880s. Unlike many greenhouse gases, aerosols are not distributed evenly around the planet, so their impacts are most strongly felt on a regional scale. When it comes to human-made aerosols, the cooling effects are also very short-lived. The carbon dioxide emitted into the atmosphere today will still be here a century from now. But aerosols emitted as air pollution will be out of the picture a few days to a few weeks from now. As soon as we stop emitting aerosols, their buffering effect on climate change disappears. But greenhouse gases in the atmosphere will continue to warm the planet. Despite great progress, there are still many unanswered questions about the competing impacts of aerosols. Different types of particles can clump together to form hybrids that are difficult to tell apart. Measuring particles inside clouds, as you can imagine, isn't easy. Changes in humidity and temperature can also cause drastic changes in how some aerosols behave and interact with cloud droplets. To make better climate models that include the effect of aerosols, we need better measurements and tools that can give scientists a certain picture of the amount of aerosols present and their properties. All things considered, aerosols are a bit of a wild card in the climate change landscape. They're not unpredictable, but we're only now scratching the surface of how they impact the climate. While most pollution is bad news, some pollution may be necessary, at least till we crack the climate change problem. Thank you for watching. See you in the next one.